Welcome to the second part of Introduction to Blazor. My name is Tomasz, and in that part we will be mainly talking about technicalities of Blazor. Let us start from that image. We can see this is the entire ecosystem of .NET 5, along with some solutions to the AI, to gaming, to cloud and other things. If we would like to find our Blazor stack, we would mainly focus on that yellow bubble, which actually holding everything related to the web technologies. And we can see, we have here our application frameworks along with MVC framework, which I guess we know very well. Razor Pages, that was introduced after MVC framework. And lastly, we have our Blazor framework, which is heavily based on Razor Pages. Because, well, we still use Razor components inside Blazor as a main building blocks. And to be honest, Razor pages are very similar to Razor components. For the quick recap, for the demo we have lastly introduced, we just created the simple components started from here, from rate component generated by Visual Studio. We've added some stars that allowing us to rate some product. Then we have added some buttons that allows us to modify those values. Then we style those a little bit, added the third parameter. After that we have removed those custom markup and introduce built-in Blazor input forms and validation. Of course, that was also styled by us by overwriting some specific behavior for those built-in inputs components. And after that, we removed entirely those forms in order to get the data from the API on the component initialization. And our main goal, our main result was the component that is looking like that. But today, as I mentioned in the beginning, we are mainly going to talk about technicalities. So let us start talking about hosting models that Blazor provides to us. The first one is Blazor Server. It is actually the ASP.NET Core solution, which is communicating with the client's browser by the signal R. We will talk a little bit more about that later in this presentation. For now, let us just focus on the main structure of that Blazor Server application. As one can tell, this structure is very similar to what we have used to see in the ASP.NET Core applications. We have this startup and program classes. We have the host.cs HTML class, which is providing a way to load the Blazor component itself. We can see that in the startup.cs we have this configure method, which is allowing us to define the sequence of middlewares. And for our list of endpoints, the fallback page is our host file, which is down here. And thanks to the tag helpers that was introduced with ASP.NET Core, we can use component tag helper that allows us to define the class that is actually the Blazor component itself. You can see it right here. and that component will be loaded. We can go to that component right now. Yes, we can see this app Blazor component with some additional markup. We have the router component, which accepts two render fragments. One is found and one is not found, based on the root data that was sent by the user with the request. That component would determine which content the server should send the client. Should be that line or another with not found result. And we can actually go into the markup of that component, the source code. Here is a component tag helper, which is defining the component's type. Yes, if we are going to follow that property, we can see that on process async method we have the render component async method called with the component type, and the result will be sent as HTML content to the client's browser. And for the router is basically the component which will gather the router data from the URL request, from the body of the request, and will display either not found render fragment or found render fragment, which is going to get the root data as a generic parameter. And as before, if we are going to follow that parameter, that property of that class, we will find the method that will firstly refresh the routing table, gather all the data we need, and after that, based on the result, it will render either the found render fragment or not found render fragment. And actually this is all to it. We can go to root view, which is just going to grab all the data from before. As we can see, we have this key value par dictionary, which is going to build the dictionary with routing data, and it will be rendered. Back to the presentation. Well, the second template that we can use is Blazor WebAssembly. The Blazor WebAssembly is the template we have actually used for creating the application. As we can see here, we have the WebAssembly.client.server and .shared. And as we can see, the structure of that project is, that template is pretty the same. We also have this program.cs file, which is going to define the root component for us, the application .razor, which is actually has the same markup as we saw before. Yes, this is exactly the same markup. What changed is the main file that the client's browser will receive from the server. In the server model, we had the host.cs HTML file, which is going to be sent by default by the server. And in the WebAssembly application, the index.html will be rendered by default if the user won't request the different page to be displayed. And one more thing we can see here, this is the line that will enable the entire communication with this with the client's browser. As we can see here, this entire process marked here. It is possible because that script will be loaded by the browser on the initial request by the client. And if we are going to talk about this underscore framework directory, all the stuff, all the JavaScript files within that directory is given by the framework itself, so we don't need to include any one of those. And of course, as Blazor WebAssembly application can be entirely independent of the host environment. So for example, we can actually deploy the entire WebAssembly application as a static files and upload those to the, well, actually any kind of host that will allow us to upload the static files, and then just request the index.html. We can also select the checkbox to create the WebAssembly application to be hosted in ASP.NET Core Server. In that way, the application will be even more resembling the Blazor Server application, because we also have the startup file, we also have a configure method, we also can define the chain of the middlewares, we also have this map fallback to the file. Instead of underscore host CS.html, we are redirecting the user back to the index.html, and the index.html file itself is basically the same as we saw earlier. For the most interesting part is how Blazor renders its contents, because we already saw those images for either Blazor Server or Blazor WebAssembly. So actually how this communication is going in the background. So as we will find out in this slide, Blazor is working based on calculating the differences between markup that will be sent to the user. So here we have some basic example. Here we have the input number CS built-in Blazor component, which is going to be defined as such list of builder instructions. We'll talk a little bit more about it later. But what we have to know is that all those instructions will generate the basic HTML markup for us. So for example, if we are going to use the input number built-in Blazor component, and if we will provide the optional minimum and maximum attributes for it and pass those attributes thanks to the additional attributes built-in parameter for that component, the final markup that will be sent to the client will resemble something like that. Yeah, here's the int max value integer. We also provide the minimum value and the value of 1, as we can see here. And let us set that the user will change the value of that input, so he will replace the value of 1 to be the -1 value. And based on those attributes we have provided, the minimum and maximum, that input, as soon as user will type the -1 value, it will become invalid, so the class of that input will be changed, as we can see here, and that final markup will be generated. Well, it should be generated. And now how the Blazor see that change? Well, at Blazor will actually going to rerun the entire build render tree method, and for each of those numbers from 0 to 6, it will just generate the values for each of those lines. So as we can see here, from 0 to 6 to 3, sorry, we have the same values for each of those lines, so no change here. But for line 4 and for line 5, which is basically representing the class attribute and the value attribute, the values will be changed, and Blazor will see those changes, and in the response of the user action will send back the div for the HTML markup. Yes, so only those two lines 4 and 5 will be sent. And that is why, if we are going to see the source code for that input number component, that's why we have those numbers typed manually, because obviously you can tell that well, that would be easier, very much easier, to just generate those numbers based on some variable. So if we can just type I equals 0 and then we'll just go with I plus plus, it would be easier. Yes, less code type. But actually there's a very good reason for that, why this is done this way. Well, because if we are going to mess up with those ordering numbers, and for example we will have the for loop statement here, we will actually going to generate something like that. Yeah, if we will have the loop 3 times, then regarding that value, it might be the same from one render to another, but those numbers will not match. So if the one execution of that method will generate only 2 instructions, that this number will be 6, and for other paths it might as well generate only 1 instruction in the loop, and that would be 5. So regardless of that, value won't be changed, and the differential algorithm wouldn't need to actually mark that line as being changed by the user. Based on that fact, this value is changed, then the algorithm will change anyway. So as I probably was able to convince you that the algorithm for sending the responses to the client is very efficient, we still can do better. We have many utilities to use if we want to further improve the performance of our Blazor application. First of such a thing is virtualizing components. Imagine that we have 10 of thousands products, for example, with the same markup. As we can see here, we use the product Blazor component with some context of the product, and in order to not force the Blazor to render each of those 1,000 or 10,000 product tracer components, we can just wrap this product Razor component with virtualized Razor component, which allows us to actually define the number of components we would like to render based on different factors. So for example, if the user will have a chance to see only 10 of those items, then we can render, for example, 20 of those, yet just to have enough data to show to the user if he would start to scroll. Further, we can use manual change detection. This is kind of the optimization when, for example, product Razor component will accept the product object as a parameter, but we, as a developers, we know that this Razor component will change only if the ID of that product will be changed. Yes, so we can express that fact and help Blazor out to render or not render the entire product component simply by passing the add key attribute, and as its value will pass the given property of the object we would like to compare. So to summarize, if the product of that, if the ID of that product will not change, and it will be in the same order in differential algorithm, that algorithm will totally ignore the rendering part of the product rate component and all components that are going to be rendered inside. So this is very nice thing to notice, especially when we are using virtualized component, because we can further optimize displaying table rows. And if it is not enough, we can still use manual redrawing. So every Razor component possesses the should render lifecycle method, and that method is going to be fired each time Blazor will try to decide should it re-render the component or not. Yes, by default this method will return true every time the Blazor is executing that, but we can simply override that behavior. So for example, if we will have the object as a parameter, and as we know from the previous demo, if in case we are passing the complex object, the Razor component, the Blazor will re-render that component each time, regardless of if that product was changed or not. Yeah, because Blazor has no means to tell that this reference, these values in that reference change or not. Yeah, so it will assume that, okay, just re-render this component every time. Which of course might lead to unnecessary re-rendering of the components. We can simply just override that behavior by providing a custom implementation of equals for our object, and based on that result we will just instruct the Blazor framework to render or not to render our component. Further, we can actually take the wheel and render the markup on our own. We can use for that the lambda expressions with the builder. This builder is actually the same builder that was used to implement that input number built-in component in Blazor, sorry. And this also can be used in another way. We'll go to it in a couple of seconds. Before that, I would mention the yet another way to further optimize our performance. as we can read in the Microsoft documentation, each time we will pass some parameters to our Razor components, the reflection mechanism will be used to actually map the references and values for the past parameters to the properties of those Razor components. And we know that reflection is not very cheap, so we can actually avoid that by not calling the set parameters async with the parameters object. What we are going to do instead, we will pass the parameter view.empty static object with no parameters to be assigned, and we'll just assign each of those parameters manually, so we can use either switch or whatever expression we would like to use. And lastly, as I mentioned in the manual rendering tree building, we can use that technique. I mean, creating the static render fragments to avoid us from to avoid overusing the Razor components. Yeah, because if we would like to have some performance boost, we can just omit the too deep render tree. So for instance, if we have virtualize a list and we will display hundreds of products, and each of those products will be Razor component, this will of course mean that Blazor framework for each of those components would need to set the parameters for that component. We'll need to decide if that component should be rendered. It will initial the change detection and all of those stuff that is related to the Razor component. So instead of just providing the Razor components inside, we can just omit that and use the classic raw markup, as we can see here. Of course, this is the good idea only when the Razor component we would like to use is it's not complicated, or we can just provide this static implementation of that component and use it instead. Of course, the list what we can do to boost performance is longer than that, but well, those that I have presented is the most recommended way to squeeze some more performance. And of course, we need to remember that those changes for performance we will only get when we are talking about overusing components like I don't know, hundreds of thousands. Yeah, this is only the matter of scale. So if we are going to use such components once or twice, there is actually no need to perform all of that. But if we would like to just read about other ways to improve our performance in the application, we can still use fixed cascading values, especially with the objects, and it is working in that way that by wrapping something with cascading values, as you can see here in the application. If we will go to, for example, I don't know, dim5, yeah, we can see here we have the cascading value component with a value of rate context, and it is working like that. That every markup, every descendant of that component will be able to actually receive the value to subscribe for the value that this cascading value component provides. So if I would go to rate component, I can see the special kind of parameter marked as cascading parameter, and without marking that cascading value as fixed, every component with a parameter marked as a cascading parameter with the matching type on each re-render will go to that cascading value component and will ask for the update for that value. And as we can read in the Microsoft documentation, it is not very efficient if we are going to mark that cascading value as fixed. Then actually there is no difference between cascading parameter and the parameter itself, because once the value for that fixed cascading value is received by the component, it will be never changed. So there is no need for rate component to subscribe to that cascading value. And of course, this is going only to work with complex object, because as we have passed the reference to that object as a value, the reference obviously will not change. What will change for sure is any of the properties inside that object we want to pass. What we also can read from the Microsoft documentation is that we should avoid attribute splitting. Attribute splitting is the thing we showed here in the built-in input number component. We can see that we have that method called at multiple attributes. Additional attributes is actually the dictionary. Yeah, we should follow the input base class. Let's find it. Input base we have here, and we can see that this additional attributes is just a parameter that will capture unmatched values or unmatched parameters that we would like to pass in the Blazor component, and this is basically the dictionary. The good example of using attribute splitting is the example we showed earlier. Here we have input number component. The input number Blazor component defines a list of parameters it can accept, but for any other parameters that is not provided for us to assign, we can just use the dictionary with additional attributes, additional DOM attributes, as we shown here. Yeah, there is no way to actually provide the max and minimum parameters for the input number component. We need to use the dictionary for that, and this is attribute splitting. About JavaScript interoperability, we will talk about it a little bit more later, but well, just a general remark that if we would like to have our application to work smoothly, we shouldn't overdo things with JavaScript interoperability. So we would do for our application good thing if we will not call this JavaScript interoperability too often. If we will be cautiously about calling synchronous or asynchronous JavaScript calls, and we can also decrease our size of our application by using intermediary language trimming, compression of the payload that will be sent to the client's browser in response. And the Blazor is also providing a feature switching for us if we would like to remove the parts of the frame that we will not use. And of course, lastly, we can just use assembly lazy loading to prevent the client's browser from downloading everything in the first request to our application. Actually, we saw the lazy loading in our demo. If we are going to open the app Razor file, we can see additional assemblies, and all those assemblies are lazy loaded. So unless user will navigate to any of those components, those assemblies won't be loaded. And now let's talk a little bit more about render modes. As we can see earlier, when we were using tag helper component, we have to provide the type of the Razor component we would like to render, but also we can provide a render mode, and we will talk a little bit more about it right now. So first things first, we can use just the static render mode. That means that if the user will request our application, the server will just send the static HTML markup that it can render based on the request, and that page will be sent to the user without any loading at all, but it will just contain a static markup and the user won't be able to do anything with it. The next render mode is the server render mode. With that, the user on the first request will receive the markup something like that. So the user will receive some non-Blazor markup, but for the Razor components themselves, the user's browser will actually send another request to the server, and the server will send to the client's browser the actual markup for all Razor components that was prepared on the server side. And the user browser, based on that token placement, will replace the content with the actual markup of the page. The next render mode is server pre-rendered. We can use that value to let the server be responsible to pre-render some response to the user. So if the user will ask the server to send the page, on the first request the server will reply with the basic HTML markup along with the pre-rendered Blazor components. Yeah, of course, those components will not be interactive either way, but user will see some complete page with the static markup and with the Razor components that should be visible on the page. After that, the client's browser will resend the request, and after that the components that was sent firstly to the user will be resent with all the necessary details, and the Razor components will be interactive for the user. If we would like to talk about WebAssembly render modes, this is something new that Microsoft introduced with .NET 5. Without those, the user was doomed to see the loading screen at the beginning of the running application. So for example, if the user will send the initial request, the user's browsers will need to actually download the entire application. So it will download the .NET runtime, it will download the static files, and of course it will take time. So instead of showing the user the complete markup, he will just see the loading message on her screen. If we would like to avoid that kind of situation, we can use the additional render modes in our server-side application. I mean, if we would like to host our WebAssembly application in the ASP.NET Core, we would be able to use render modes like WebAssembly or WebAssembly pre-rendered. Their behavior are exactly the same as we shown earlier for the server Blazor. So, for example, for WebAssembly pre-rendered, instead of sending to the user the initial markup with the loading message, the pre-rendered markup with all the Razor components in their place will be sent to the user, and after browser will create the second request in the background to the server. The rest of the markup will be generated and the Razor components will be able to receive the user's inputs. Couple things worth mentioning about JavaScript interoperability is that we can work both ways. We will get into that in a minute. But first, let us state that calling JavaScript is asynchronous by default. If we are going to use Blazor Server, we have no other choice but to call JavaScript functions asynchronously. Well, the reason is very simple, because Blazor Server will communicate asynchronously with the user's browser, so there is actually no point of calling synchronous JavaScript in asynchronous communication. But for WebAssembly, if we perfectly know that our JavaScript is synchronous, we can additionally save some time by just calling synchronous version of the JS runtime, as I saw here. Yeah, this is the default IJS runtime, which is asynchronous, and it will serialize .NET objects passed as a parameters for the JavaScript function. Those will be serialized to JSON file, and after JavaScript will return some value, that value from JSON object will be deserialized to .NET object one more time. So as we can see, we can just avoid using asynchronous call by using interface in process runtime, and the same thing goes to the serialization. The serialization cycle, we can just use unmarshaled runtime. And in other way around, if we would like to call .NET methods from JavaScript, we can of course do that. What is required from us is to mark the method we would like to call by JS invocable attribute. We can also invoke static methods in that way, as the methods that are not static. To do that, we would need to convert our instance of the object by using .NET Object Reference class. It will actually allow us to execute the create method with our object of the type tValue, and it will pass, and we can pass that .NET Object Reference to our JavaScript. Of course, with JavaScript interoperability comes a price, so we cannot handle circular dependencies for example, serializing 3 nodes is impossible to pass that kind of data to JavaScript. For a simple reason, we cannot just serialize that kind of structure because of circular dependencies inside it. Of course, as we mentioned earlier, Blazor is calculating DOM diffs to send the user the changes that the browser needs to refresh to show user the progress. And that means also that if we are going to use JavaScript methods to render some markup on the user's page, the Blazor won't see that kind of markup is there. So the actually Microsoft documentation is recommending that if you would like to render that kind of markups, for example, if you would like to render a Google map based thanks to the JavaScript library, we can do it, but the recommendation is to just wrap the JavaScript output with some additional DOM tag. And well, we just need to make sure that this HTML content of the tag will never be changed by the Blazor itself. And of course, there's another limitation, this time binded to a signal R. This is basically the bridge between Blazor server and the browser. Well, JavaScript cannot just return any size of the object because payload is limited by signal R. We can also tweak that in the settings in our server. The same as we can tweak the timeout for our JavaScript to have to create the response. And lastly, we will need to deal with server or WebAssembly pre-rendering because, as I said earlier, if we are going to use pre-rendered render mode, the initial markup will be rendered and all the Razor components lifecycle methods will be run on the server without actually sending that markup to the user's browser, so there will be no way to actually execute that JavaScript calls. So we need to remember that. And lastly, I have prepared some examples of Blazor libraries. This is, for example, the free one, which is defining some basic components. We have calendars, we have dialogues, some basic filterings, table components, and so on and so on. We also have some charts even. Of course, there are also paid solutions like Syncfusion, which is giving us much more freedom if it comes to choose the component styling. We even have our rating components which we have created in the previous demo in the previous session. The other one example is Telerik, which is also providing for us some basic components. Of course, there are a lot more libraries. Those are just main three that I found on the internet, and I used those while I prepared for that. While I preparing for the presentation. Lastly, I would like to just mention what we have new in .NET 5. With the newest update of .NET 5 framework, we have some performance optimization for WebAssembly. We can finally provide our own CSS class provider. If you would like to know what this is, I will return to our example of the input number. If we will recall, we have class valid, and suddenly out of the blue, if the user will change the value to the invalid value, that class would be changed to modified and invalid. Well, this is the thing that this file CSS class provider is responsible for. So now we can just provide any other classes we want to apply based on the input actual state. So the state would be valid or invalid, pristine or touched or dirty, like something like that. Also in the .NET 5 we introduced the new input Razor components like input ready buttons and input files. Assembly lazy loading is also introduced only in .NET 5, as we can see in this presentation when I shown you the actual demo we have used in the previous session. And .NET 5 is also providing us with optional routing parameters, because without it Blazor wasn't able to actually parse the markup we used to use in the ASP.NET MVC or Razor pages. If we can just open that file, we can see here we have a root attribute. This is very known attribute for all the ASP.NET developers. And here we have the parameter with the condition it should be int, and it is optional. Before .NET 5 we would actually to define it in that way. So if we would like to have this ID parameter as optional, we would just define two roots, one without that ID and the second one with the ID to be mandatory. What next? .NET 5 also introduced the CSS isolation along with the JavaScript isolation. It will introduce element reference methods like focus async, and what about this function is we can now actually capture the reference for any HTML tag and run some methods on that reference. So again, for example, if we would go to wrapper components, we can see here we have the container component, Razor component, and we are capturing the reference for it. And on that reference, you can actually call the method that was provided by that component, but from .NET 5 we can also just use the same syntax for any kind of markup. So let us define that one, element reference. Let us define the private field of that type element reference, and we can see that I can just call that reference with the focus async method as here. So we can imagine that based on some condition, that element would be changed to focused. We already talked about virtualization, so nothing for me to add here. And lastly, what is the future of the Blazor framework? Well, the first thing would we like to receive from the future release of .NET is the Blazor ahead of time compilation. It should be here already in .NET 5, but Microsoft told us that this feature was delayed and it will be available in .NET 6. Also, Microsoft mentioned in early days of Blazor that it will also support the mobile devices and Electron applications. And basically that's it. If you would like to further read on the topic, I recommend to check out the Microsoft documentation, the books from Alan Freeman, Pro ASP.NET Core MVC, Blazor University page, Visual Studio Magazine, of course. It will introduce many more news for Visual Studio World, but we can find many tips for Blazor itself. And actually this is all for me. Thanks for the patience for listening. That's all for today's presentation.